Hello, everyone. I'm Dana Johnson, and with me is Evelyn Model. We are your co-hosts for the Interplay Podcast, a place where we ask and answer questions about everything non-speaking. If you're an individual who is non-speaking or unreliably speaking, or know someone who is, this podcast is for you. Come join us as we chat about the things that we have learned from the true experts, the autistics themselves, and listen in when we interview parents, researchers, and more.
So that's wonderful in terms of when I'm thinking too, and I'm going to try and relate this back to what, we do at the clinic and looking at the, like you said, subtypes, but then the important part of that is the different interventions. I mean, it's so important to get a good profile and understanding of this so that we can then, like you said, ensure that they're getting the support that their body needs. And that's the biggest thing. I think that in the intervention types that we have today, which tend to be somewhat polar opposite of the behavioral approach and a developmental approach, relationship-based approach, and they don't necessarily always see eye to eye, which is another kind of discussion. But I think that to kind of take that information, especially when it comes to the motor, in terms of how important that is. And then also at different developmental times, like you were working with younger kids in your initial research. I primarily have individuals that come to see me mid-teens all the way up to 30s, and that's the first time that they've ever had that, and they've established these motor patterns that are very well ingrained, and very difficult for them to kind of deviate from because of that motor practice over and over, and myelination that's happened. So I think that's also something that is really important to consider as well.
Yeah, no, that's very important. And also, I mean, we've seen also teenagers and adults in the lab, but what the parents tell us about their kids transitioning into puberty is that the changes are so dramatic at times that they think it's like another child to them, and that happens to everybody, like neurotypicals too. But it's sort of, you would go for a reassessment, and there's no such a thing, but at the moment, but one would need to reassess the whole person up until that point, and then begin again with that in mind, that puberty is going to change everything.
Yeah, no, that's huge. And I think that, again, in some of my parents that I work with, because they're often focused on the autism and not so much about some of those internal developmental changes, they don't necessarily jump to that all the time, and nor think that they may make, as when I was going through puberty, I mean, it was sometimes drastic, the mood swings or whatever you might have, and then on top of that, you don't have communication,
right?
So it's those things that absolutely to keep that in mind, and really important. So then, Dr. Torres, your current research, I mean, is still based on that initial study, and you're just, as you would say, continuing on with that.
Yeah, it's a very complex problem. So we're still working on the same issues, but just expanding from a person's centered approach to dyads and groups, social groups. So now the same methodology that we developed to study the body of the person with many different nodes, interconnected nodes, we expanded to two people interacting. It could be a therapist and a child, or mom and a child, or two children, and so forth. And so that's one part that we expanded everything to study dyads and triads and social groups. And the other thing is we a lot of what we do happens in the lab with instrumentation that is expensive and very high grade and so on. So another portion of the lab started to move into the path of scaling all of these massively, so we can sample a lot of people easily with off-the-shelf technology like webcams and the Apple Watch. And
I was going to say, like the wearable technology.
The wearables, yeah. So, but the wearables that are really affordable, off the shelf, that people can use everywhere, and or pretty much everywhere. I mean, pretty much everybody has a cell phone, at least in the first world countries. I mean, you go to Africa or South America, it's different ballpark. But at least in our society, we can then expand what we have found in the lab to a larger scale. And so that's another component. And when COVID hit, so back in March, that we had to go home and close the lab, and until now and the next year is going to be like that too, we had to come up with a pivot. And how do we continue doing this type of research, which is very physical, remotely? And so we started to develop new methods to analyze the data remotely, to collect data remotely. So we came up with this concept of our lab in the box kind of thing. So we send the person a box with a webcam and Apple Watch and so on, and instructions. And it's like plug and play, and then the person can collect data. And this concept is also in other areas that I collaborate, other labs that I collaborate with. So it's not only my lab. We realize this, and it is primarily people who study motion, like myself. And so I have a collaborator at Stevens University, for example, who has it's a little suitcase, and you have different soles from different shoes of these different sizes that you can put the inner soles you can put in the shoes, and they have pressure sensors and motion sensors. And so when you're doing your therapies or when you're walking around, and you can collect that data, sends it, with an Android phone, you send it to the cloud, you analyze it in the lab, so you send this thing to the home, and you can get this. Same with our lab in the box, you get the webcams and so on. So another thing we did was to take the Zoom, because everybody is using Zoom these days, and turn it into a study of social interactions. And so I can take the Zoom information, take the faces, the eyes, everything. All of that is motion, because if people think of movement just of big movements, but this is all motion. And we can study all the micro motions of the face of the person and extract emotional affect, and so on, as the two people interact, or as the group. We have a Zoom of 10 people in my lab interacting in a lab meeting, and we can totally analyze the facial expressions and the voice tones and everything. All of that is motion. That's the interesting thing. And so we turned COVID into a data collection.
It's so, I mean, I hear these stories over and over again, and we were forced to, we had to, I never thought that I could do, what I do over Zoom. I mean, I did have a lot of clients that were out of state or whatever, but it wasn't something that I thought I could do continuously. And it's just been amazing. I look at it, with the silver lining, because I've had so many opportunities now to connect with others outside of my inner circle. But I think about all of the movement, and when I talk with parents about, like what you said, everything, we don't realize that we're moving constantly. We don't realize at all. And then when I talk with them about their son or daughter who have that brain body disconnect, where their brain knows what they want to do, but they can't make those connections to organize their body, and obviously there's the sensory information coming in, all of that's affecting it. But I'm reminding them over and over that their bodies are moving all the time. So if you don't have that connection, you're really working in a state like hypervigilance here. Like we don't have that feedback. It's not the same as us. And so to say to them, go and do this quote simple movement that we feel would be simple is like impossible for them.
No, it's mastering a very complex thing, and you can see that hypervigilance that you talk about in their heart. We when we put sensors and measure their hearts, the heartbeat and the interval timings, and we can see the signatures of someone of a neurotypical person who would be in fight or flight mode all the time. Very hyper. Yeah, it's really, it's real. I mean, I wish, I mean, it'll be more mainstream. It'll be more common as the wearable sensor revolution penetrates the population, and this becomes as common as an activity tracker. You know, now people go wear a Fitbit and go and say, oh yeah, I burned so many calories and I walked so much and I slept so much and so forth. So it'll be as common as that. You'll have your app that measures your heart activity as you're doing these things. And there are some apps out there. They're just not tailored to measure what you do in autism, but or they're not yet at a point, like, for example, it wasn't trivial to hack, you know, get all the information out of the Apple Watch, right? The Apple, they provide some tools, and same with the Fitbit. The Fitbit provides some tools that some APIs that somebody with computational skills, with programming skills, can go and download the entire activity records for, say, the last 2 months. You want to see what, and you can see the graphs and everything. But it's not like something that the common person can do. But the moment that becomes available and massively scalable like that, people will start seeing what we already know for years, and they will start feeling the guilt, I think, because they will see what they put these kids through unknowingly, and in some cases knowingly, because by now we've alerted a lot of folks that this is the case and they don't want to listen. They put their interests above the interest of the kid. And so you can see, as a researcher, you can see the crowd of consumers that consume that literature. You can see the people that want to help and make a difference and follow the science. And you can see the people that disregard it and say, we're going to do what we're doing anyways, because this is what it is. You can see that. So, but as this becomes inevitably more like massively available and people start seeing it, you can't deny it. It's there. It's so real.
Yeah. And I just can't wait for that, because, you know, I one of the things that I felt has helped a little bit with understanding with some of the the disconnect between the brain and the body, to illustrate for parents, is with ocular motor, you know, because it is such a fine motor movement, and typically parents wouldn't jump to say, oh, he's got ocular motor difficulties. They'll say, well, he can't do this or he can't do that, gross motor wise, like you were talking about, the tiny movements, and then when I'm doing, you know, an evaluation or an assessment to look at ocular motor, and then, you know, they realize, oh, wow, this is a simple movement, like tracking, or, you know, following a balloon with your eyes without lifting your hands, or they can't do it. Oh, wow. And I try and make it so that it is relatable to, this is what's happening with everything in their body. And it's reminding, you know, because we're taught, I feel, as, you know, parents, as a society, to take what's on the outside as exactly what they're wanting to do, purposeful, volitional, how they feel, like you said, all of those facial expressions, as valid and reliable. And in our population that we work with, it's not. And it's very difficult, I think. And like you alluded to, you know, some of the individuals that are professionals working in a certain way, they're like, that's what we do, we're going to stick with it. But yet they're not open to this. And I think the key is, like you said, they need to see it and hopefully, soon with that technology to be able to tap into that. So you have, I think, answered this question, but just, I know you talked about the big thing that you found, but what is the biggest surprise that you felt came out of your research?
The biggest surprise, well, that was the biggest surprise, that spontaneous movements, parts of the segments of the actions that are beneath awareness are so well preserved in autism, because it got me to think there might be systems, subcortical structures or systems that are peripheral, which are usually doing this kind of, housekeeping, that might be operating at a level that is comparable to the neurotypicals. And so that is, even though we see, that subcortical structures like the basal ganglia, cerebellum, the substantia nigra, and the striatum, and so forth, are genetically have problems. So they have their genes that express in those tissues that you can see that they are problematic in autism and in neurodevelopmental disorders in general. But somehow the system, surprisingly, overcame whatever glitch is there, and that part of the motion is actually informative. And so it's like very surprising to me, because it's unexpected. I mean, the research with neurotypicals, the motor control research, and none of the research looks at these types of motions, because most of the research and the experimental assays out there are goal directed. So you look at the goal directed portion of the movements, and that's what is studied in neuromotor control. So to actually tap into these movements that are incidental to what you're intending to do, or that are supportive, or that are spontaneously happening, they don't have a goal per se. They're uninstructed. They just happen continuously. Kind of, they add fluidity to what we do, and they also, we call it the listening movements, because in a different context they will switch signatures, okay. Whereas the ones that you intend to do in a different context will retain the same signatures, because that's the main difference between these two types of movements. If you were to blindly separate them from the trajectories of a continuous motion that you do, you know that the ones that are preserving those signatures are intended. Those are deliberate. There is an intention behind that. The other ones that are changing a lot are the ones that are spontaneously happening without instruction or prompting and so on. And the fact that they have signatures that are comparable to those of neurotypicals was the surprise. So I mean, I think that's like the big surprise. The second big surprise was when we started to gain access to large open access databases, and they studied autistics by thousands of cases across the lifespan. So now you have access to like all the way from 3 years of age to 60 years of age, and you see this progression. And so the surprise there was that when we study involuntary micro movements of the head when they're laying in the scanner to get an fMRI, and they are asked to not move, because you're in the scanner. If you move, the image blurs, that blurs the image, so you have to drop that frame. So when they're scanning you, they do a lot of these frames, and so they ask you not to move. So like when you go and they say breathe in and stop breathing, and then they scan you or something like that, or they ask you simply remain at rest and don't move. try not to move. So turns out that the autistics do move a lot involuntarily. They're trying, but the body has a lot of involuntary motions. Yes. And so that when you look at it in the lifespan, by 40, you start acquiring the signatures of somebody who has that by 60 in the neurotypicals.
Oh.
So it's like accelerated. So it's like you would think, right? And I mean, it's just a surprise. It was a surprise. So it's like, okay, so there is more and more randomness and noisiness and so on already by 40. And in autism, when you look at the transitions across the lifespan, than controls would have. Let me turn on the light a little bit because it's getting darker. So that was another surprise. And lastly, in the last few months, I took an interest in the genomics and started to look at open access databases for the genome. And I've been now working on that. And I sort of came up with the idea of looking at a gross test. If you were to eliminate all these genes that are associated with autism, what happens to their expression in the tissues? What are the tissues that are maximally affected if you were to do this kind of gross elimination, right? I mean, of course, you can do gradual and combinations and so forth, but it's just delete all of that. What happens to tissues? Which tissues are the most affected? And when I did that exercise, I then also compared to schizophrenia, depression, these kinds of psychiatric disorders. And then I compared to neurological conditions like Parkinson's, ataxias, and neurological conditions. And then I also compared to like none of that, like cancers, autoimmune disorders, so like just to see if it was a fluke what I was going to, because so systematically the overlap was with the neurological conditions. So the tissues that are maximally affected when you eliminate all these genes. And so you have all of the things that get affected in these neurological conditions that affect movement and emotion. So the basal ganglia, the striatum, substantia nigra, the amygdala. And so these are overlapping with the tissues that are maximally affected in the neurological conditions. There is some overlap with schizophrenia and depression, but it's really the neurological conditions. And of course, there is no overlap with the other, cancers and all of that, because that affects tissues that are specific related to those. Colon, breast cancer, colon cancer, whatever the type is, and you can see, and that's just like a sanity check, like, well, is this actually a fluke or random? So that was somewhat of a surprise. I mean, not entirely. It was like, yeah, makes sense, but it was a surprise how clean that came out, because this is the type of stuff you cannot make up. I mean, it is what it is. You just put it through, and then you come and then you're like, wow. And this was an exercise to basically go into the fields that have created targeted therapies and, that are targeting the genome and so forth, and see what has been done there that could benefit this other group, right? But it's a very gross exercise, but it's a starting point to probe into the genome and begin to see selectively how we can address different tissues that are impacted by it. Particularly because my interest lately, and you're asking me what my research is, So beyond continuing that line of research about autonomy and agency and so forth, and also trying to connect it to the genome. So like, how do we read out the transcriptome data of the genome in like induced pluripotent stem cell research? How do we create new computational methods that read out that data without throwing away any of the genes? Because in some of the research, when you look at the methods, since these are thousands and thousands of dimensions, you know, you got 26,000 genes tracking daily as these cells become neurons. They throw away a lot of that information. So you get maybe 5,000, you track maybe 5,000 genes. But when you do it longitudinally, you see, when you look at the longitudinal data, looking using the methods that I'm developing, which consider all of the 26,000 and so on, you see that some genes that are turned off at the beginning or not as active turn on later on. And so this is just neurotypical development of induced pluripotent stem cells becoming neurons, which will eventually become part of the brain and so forth. And so the gene expression, you track the gene expression, and you see that some genes that you might not consider, you might drop out of your count because they're not as active in day one or in the first week that you're tracking, then actually become active and have an impact on their neighbors. So the techniques that are currently being used to do, genomic, transcriptomic analysis and so forth need to be updated, need to be improved. And so that's one area that I want to use my skill in math to improve those methods and ultimately connect that to the behavioral
what you're doing
issues that we're how do we improve that, and how we do connect to autonomy? What is it that we need to improve spontaneous autonomy?
Fascinating. Like, I just, mind blowing in my brain is just going so quickly because I love this kind of stuff. Like I said, a research junkie, self-proclaimed. So just this really, I could speak with you for another 3 hours probably and talk to you about details on this and what you're doing and how you're doing it. But unbelievable. And I'm so grateful to you for doing all of this research, especially when, day to day, I work with my clients who I want to do the best for them. And I learn obviously from them as they're the experts with their bodies, but certainly from you and individuals like you who are doing this to help, support what they need and what, other autistics are, showing you and through your research. And I think, yes, I'm grateful. I truly am for your team. So last question that I have for you would be, what have autistic people taught you?
Oh, quite a bit. The resilience they have, and the patience with society, how much they long for the social touch, and how I think the main thing is what I've learned as a scientist is, how science is so focused on learning the causes of disease or phenomena or, whatever. So what I've learned here is that understanding the causes of autism, and I think that's an intractable question, but suppose that you could actually make it into a tractable problem, it's much less important than being kind. And that actually treating the person as you would treat yourself. And so it's been a very arduous journey, let me tell you. It's very hard for me, very hard, because I relate to autistics and at a deep level. I don't know why.
Mhm.
I do. Just from that very first time that I entered that room, and it was a general consensus between me and the rest of the kids that we're okay and that we're going to share this time. And there was not a word there, but something
You knew.
we knew,
Mhm.
we all knew, and we all came to that consensus. And I sat down on the floor, and they came and they checked me out and they touched me, and that was what I learned. That was my lesson right there. And I said,
Mhm.
you are so human.
Mhm.
We are so in this together. And it's been very hard to see how this very trivial concept, basic human thing, is so hard to get.
Yeah. Yep. Yes.
That is my
Absolutely.
biggest lesson. Like,
Mhm.
why? And it still is very puzzling to me. Why are people out there who cannot see it?
Mhm.
So,
Yeah.
um, yeah, I've learned the resilience and the creative ways of coping and dealing with or all this neurological and it's not just the nervous system is only really a way to measure things that is accessible, that you can measure things in a non-invasive way, and
Mhm.
just go home and do this at home kind of deal with the sensors now. But it's a systemic problem. You have also the metabolism, and you have the microbiome, and you have, this is a systemic thing. The nervous system is just a way easy, cheap to measure it, to track it, because it
Mhm.
has dynamics. It happens moment by
Mhm.
moment changes, and you can track these. So the complexity of this problem is enormous, and yet it's enormous to study, and it's enormous for somebody who has the problem. How do how they work to function and to fit and to
Yeah.
be social and be accepted, and how harsh the judgment is on the other side.
Yes.
And that's the part that I just don't understand. Why should
Yes.
there be this judgment uh, based on assumptions of something? You ought to actually open your mind that this is
Mhm.
not it. That you have a very limited piece of what's happening,
Mhm.
very very limited, and it's even misleading.
Yeah.
So
Yeah. Thank you, Dr. Torres, for not only contributing to the science, because we need that, but also, I mean, your heart. You can see it,
thanks.
and I'm just grateful again to you for that, to see that we're all human, and we need to be kind no matter what, and that if we can just take our assumptions, presumptions, and put them aside and really work with our individuals, our guys, I call them guys, even though the guys and girls, and just really support them and in the way that they need it, it is life changing. I mean, they teach me things every single day. And I just respect them in so many ways. So I am grateful for you, for your time, for what you're doing. And I'm going to be including in the podcast links to the website, what you're doing, so people can learn more and keep up with what you're doing, because I certainly am going to do that, and to keep tabs on that, because the whole it seems like it's your well, I didn't have anything else to do, so I looked at genomes today. I'm like, it sounded like that. It was like, oh, it's just kind of like a pastime. I didn't have anything to do on a Saturday, so I just looked at all this stuff. It's just so fascinating to me, and so I definitely want to learn more about that aspect of it too. So thank you so very much. I really appreciate it today.
You're welcome. And check out our, we had on Friday a webinar live with Ann Donovan and Jaswell Brinkram.
Yes.
Yeah.
Yes.
And so we got so many hits that we decided now to have like a podcast. So we'll be in 2021 where we have these kinds of conversations. And it'll be great to hear people send us their questions, and
Mm-hmm.
we're going to be talking in general about the other people's research, and even just things like horticulture and the benefits that it had, the therapeutic benefits that it has for everybody, and all kinds of things. So check us out at the NJA's website, and send us your questions and so forth, and we'll be happy to to share that with everybody.
Excellent. Well, I am definitely going to tune into that, because I had to listen to the recording. I didn't get to attend that day, but I only heard amazing things about it. So the fact that you're going to do a podcast, like 3 of my most famous or favorite people, I'm definitely going to be doing that. So thank you again, and really appreciate your time.
Okay. Thank you. Bye.